Hello everyone. Today we are going to learn how to combine the forces. In the universe, we don't have single isolated force. According to the Newton law of motions, every action which is force has opposite reaction in another force. So in general, force exists in the form of pair. So uh, in these sections, we will learn how to combine them. Uh, some force are in the same horizontal directions. I mean, uh, same straight line, and some force are in the uh, different directions, and some force are in the uh, multiple directions, right? So we will combine this force uh, in order to get the total force, or we call the resultant force. Okay, combining forces. Uh, for example, uh, a tennis ball is dropping from the sky, right? This is a tennis ball. It is dropping. It is moving down because of its weight. mg. Let's call this is weight. And another force is acting in the upward directions, which is the we call dragging force or air resistance, right? And how we calculate this? Our resultant force will be equals to weight minus Ft. This is the two forces are combined here, right? In order to get the resultant force. In the same way, if you are pushing a block with certain force, right, and the block experience the frictional force. Let's say this is called F, small f, and what is the resultant force? Fr will be F minus F, right? This is the resultant force against the friction. So we can combine the two forces here. What happens when the forces are in the different directions? For example, uh, one force is acting in towards the east and another force is acting in the downward directions. Here's one example here. There are two forces acting in the shuttlecock, and its weight vertically downward. This is weight vertically downward. You can see here, and horizontal pushes the wind, and this is the wind. Wind is uh, pushing in this direction, horizontal direction, and so we can draw the vector diagram. This is the horizontal directions, right? Uh, horizontal directions, and another one is the vertical direction, right? And this gives the resultant uh, force. Okay, we can combine using this. What is the resultant force? R equals to just 6 square plus 8 square, right? This is just the Pythagoras theorem. We can calculate R is 10 Newton here. And what is the direction? Which is theta is the directions of the horizontal force. So you can get 10 theta equals to how much? Uh, 8 divided by 6, 4 by 3, and theta equals to 10 inverse 4 over 3 equals to 53 degree. So we calculate the magnitude as well as the directions of these two forces acting on the shuttlecock. This is very simple problem. two forces are acting perpendicular each other. Now, another problem we have like two string, two string are this and there is another two string are supporting a weight stone, right? Not one string. And in this case, the the magnitude of the force of two string are different. One first string is 1 Newton and second string is acting the 0.58 Newton. So what is the question here? Calculate the horizontal component of the tension in each string. If the tension is a force, just this is the force. And why should these two forces be equal in magnitude? Mhm. Let's calculate one. Two forces are here. This is, let's say, F2 and this is F1 and this is the weight of stone. We have three forces here. Okay, calculate the horizontal component of the tension. Horizontal component is this directions. This direction is horizontal directions, and this is the horizontal directions, and this is the vertical directions. Okay, never confuse with that. For string one, for string one, uh, theta equals to 60. So what is the horizontal? So for string one, we can calculate this directions. Means F1, let's say X is the horizontal and Y is the vertical, right? Equals to F1 cos 60, which is equals to 1 into cos 60 equals to 0.5 almost. And in 2, for string 2, what happened? For string 2, theta equals to 60, 30. So F2x equals to F2 cos 30. This nearly equals to 0.5. So these two forces are equal in magnitude because the string is in the rest along the horizontal direction. It is not moving this or this. So this force must be equal to the force in the other directions in order to get the equilibrium position. Okay, so they are equal. That's fine because two forces are balance each other. Okay, they are balanced because this string is not moving in the horizontal directions. And the B, what we calculate? Uh, Calculate the vertical component of tension. Okay, vertical component is, let's say, vertical component this directions, right? What is the this directions? Okay, this is 30, and in the vertical component this directions we have F1, let's say Y equals to F1 sine 60, F2Y to F2 sine 30. So uh, vertical components of this string that equal this equals to 0.86 Newton, and now F2 equals to 0.58 into sine 30, which is 0.29 Newton. Use the answer B to calculate the weight of the stone. In this case, the um, vertical component of this string are acting in the upward directions, while the weight is acting in the downward direction. So the weight of the stone is balanced by the vertical component of the string. So that is the Fy equals to F1y plus F2y equals to weight in the number C. This is the C. So this is gonna be equals to 1.15 Newton. Uh, in D, draw a vector diagram of force on the stone. Yes. Uh, and this would be triangular force. Okay. Let's try. Uh, we have force F1, F2, and weight. Right. Let's do some string F1, which is acting in these directions, and another is the F2, and there is a angle between the F1 is 90 here. 90. You can see from the string because 180 and 90 minus this is 90. So this is the weight. Weight we call the FR resultant force. Okay. Mm, This is upward directions and this is downward direction. So this is the force. Right? This is a downward force. Let's different color. This is the downward force FR, and another force is F2. F2, let me green. This is F2, and and this force is F1, and this angle is 90 here. Okay, other directions, and this is the resultant force. So uh, this is a triangle, right? The triangle, and we see that uh, to FR square equals to F1 square plus F2 square, and that gonna be 0. This gonna be 1 square plus 0.58 square, which is 1.15 Newton. And the same force we calculated previously using the another techniques. And what is the last? Use the diagram to calculate the D, the weight of the stones. So we calculate the weight of the stone. So this is C and D. So in this way we can combine the more than two forces.